So I made a quick little table to highlight some of the big topics that come to mind when comparing across these two platforms. Ultimately, I suggest that you use the platform that you are most comfortable with, but here are some of my general thoughts on the two. The first consideration, I think, is flexibility of priors. Mplus has a limited set of priors. They use just a small number of conjugate priors like normal, uniform, inverse gamma, inverse Wishart, and so forth. These priors are typically perfectly fine, but sometimes you may want to stray from this list and use another type of prior or even a completely different strategy for prior situations. So for example, I have a paper published in the Structural Equation Modeling Journal in 2021 with my colleague Haiyan Liu. And in this paper, we showed that there may be sometimes an advantage to using a different prior strategy on a covariance matrix, which Mplus does not offer. So when you're working on basic issues and the priors are not causing estimation accuracy problems, then the set of priors Mplus gives you is great. However, if you need a different type of strategy, which some of my work focuses on, then it might actually be better to move into R where you can use a different set of priors. The Mplus priors are actually very well thought out, but R does offer more flexibility, especially given that you can run stan and bugs through R. This allows for a wider set of priors at your disposal. So I've even worked on projects where we've created our own prior forms that did not have known distributional forms. Mplus cannot handle this at all. So the question about priors is a first issue that you would need to think about. You'd want to think about which prior settings you needed and then look to see if the platform, the software you were using, was compatible with those needs. So next I list an estimation point. When constructing the estimate of the posterior, different MCMC sampling algorithms can be used. We talked earlier about the random walk Metropolis-Hastings algorithm, Gibbs, and then Hamiltonian Monte Carlo, or HMC. One of the benefits of HMC is that it can really speed up mixing time with the use of momentum variables that jump through parameter space much faster than a random walk algorithm can. If you need something like HMC, then that means you need to use R, likely RStan. Mplus has Metropolis Hastings and a few variants of Gibbs, but it's not yet extended into offering HMC. However, it may be that something like Gibbs will work great for you. 95% of the time, this is likely to be the case. So this isn't necessarily a knock against Mplus, but if you do need something like HMC, especially to speed up mixing time, then you would want to go with R. Next, I list a bunch of the most common modeling situations, and I showcase that Mplus and R can run a wide range of models. I'll say that Mplus has superior mixture modeling using categorical latent variables than any R package that I've played with. So for mixture models, I have a bias toward Mplus, but I think for the other model forms overall, it really doesn't matter, and it comes down to preference because we have so many R packages that have been well developed, and Mplus is obviously a well-developed software for anything that is regression-based or latent variable model-based. If you have more familiarity with R, then the various Bayesian packages, I think, will suit your needs very well. If you work mostly in Mplus, then it can definitely get the job done for you, but you may want to consider extracting your chain results to make nicer looking plots in R. But Mplus is certainly a terrific program for Bayesian analyses, especially for latent variable models.